Yesterday, we started experimenting with Codex from OpenAI, and I was really excited in that video. And I have to say that the only time since I got the access yesterday to Codex, the only time that I've experimented with it was during the recording of the previous video. So you might want to look into that. I'm very new to Codex, and I'm still very shy of what it can do. So I'm super, extremely excited about it, about experimenting more with it, and about making more videos about it. And maybe, of course, I'm probably at some point going to implement Codex features into Alter AI, which is the platform that I've built, and you can check it out for free. You can also get free credits to try it out on Omni. You have a lot of examples that you can try out, as you can see here. So that's that. Look into Alter AI and Omni. You can experiment with it for free, and also you also have this how to use video. You can also tell other people about it. I would really appreciate that. Now, back to Codex. Today we're not going to look into the sandbox, even though I'm extremely excited into experimenting with the JavaScript sandbox here because if you've watched the previous video, you've seen my overwhelmed reaction. And there are a few of things to try out here, and in future videos we're probably going to come up with other types of examples, something more maybe interesting than this one. Now today is not about the JavaScript sandbox. Today we're actually going to look at the examples the folks at OpenAI posted um, over here in the documentation. So maybe we're not actually going to try all of them, but just a few of them. Let's look at this one. Create, so natural language to OpenAI API. Create code to call the OpenAI API using a natural language instruction. This is interesting. I'm not really sure if I understand. Create code to call the OpenAI API using natural language instructions. So natural language to OpenAI API. So, create an open util exposes the following. Util.openai authenticates and returns the OpenAI module which has the following code: the number of max tokens, a measure of randomness. Create an OpenAI completion starting from the prompt once upon no more than 5 tokens. Does not include the prompt. And you get the response sample response. Let's see what this is about, even though it doesn't seem pretty interesting to me. So we have the DaVinci Codex. All the parameters are set up here. The Codex models are currently in private beta. Usage is free. Let's do submit. So I would think create an OpenAI completion. This actually, starting from the prompt, once upon a time an AI no more than 5 tokens, does not include the prompt, and you have the print completion. Okay, so this is actually for someone who doesn't know how to call the OpenAI in Python, and this actually creates a completion. You just have to say the prompt. It actually fills in the prompt. You also specify the tokens and does not include the prompt. So the tokens, the number of tokens doesn't include the prompt, and then you print the completion. So this is sort of like service inside of service inside of service inside of inception inside of all that stuff. Yeah, might not be very interesting. Next, what do we have here? Natural language to Stripe API. Util Stripe authenticates and returns the Stripe module. Create a Stripe token using the credit card, and you have this. So if you remember from yesterday, in their documentation they said that you can use Codex on anything that has an exposed API, and they give us two examples here: OpenAI API and Stripe API. Maybe we're gonna look into more details into these later. SQL translate natural language to SQL queries. So PostgreSQL tables with their properties, employee ID, department, a query to list the names of the departments which employed more than 10 employees in the last month. And you get the response, which is a SQL query. So you translate natural language to SQL queries. Now, this, let's be straight here. This is not for no code, for people who don't know how to code, because people who don't know how to code, they don't know what the SQL query is. So first and foremost, as much as a lot of people try to say that, and I myself tried to say that this is going to revolutionize the world, you have to keep in mind that no code, the no code tools like Bubble and other tools like Webflow, Codular, even Codex, these still imply that you have to know algorithms, you have to know some sort of a programmatic thinking, problem solving. Otherwise, these are not actually super helpful to you. I would have to say that people with very solid knowledge of algorithmic thinking and also with solid knowledge of algorithms, of course, problem solving, they will probably be the ones that have to gain the most from Codex and no code apps. Because you still have to know how to think and problem solve. So it's not like you take someone from the street who's been working in, I don't know, the restaurant business and give them the no code tool and give them Codex and they're gonna build the next $1 billion business. I don't think it's gonna work like that. Anyways, Python to natural language. Explanation of what the code does. Now this is interesting. Let's open it in Playground. So this actually, you're giving it a Python code and you're asking for the explanation of the code. We have remove common prefix, ax prefix, prefix, completion. What this does is probably, so we have a function called remove common prefix. You have ax the prefix and the ws prefix. Ax completion is ax of completion. Ax of completion is ax of completion string. This is interesting. I don't get it like 100% unless I would actually try to see an example of it. So you pass it 3 parameters. Let's actually see what we get. The code above is a function that takes 3 arguments. Wow, that is enlightening. Let's rerun it. One more time. Explanation of what the code does. So this isn't too helpful. Interesting, doesn't want to work. Explanation of the code above. So this isn't running. Now it's interesting. So you have the codex. These are this is where you select the engine. You have the GPT-3 engines, you have the instruct engines, and you have the codex engines. Now let's see, if we do the DaVinci, the thing that was over here disappeared. We still have the parameters that we can play with. If we go back to the DaVinci Codex, we can see that there is another thing here. Now, in this case, you have pre-selected plaintext, but you also have Bash, C#, Go, Java, JavaScript, Python. So these are actually, you probably explain here in natural language in the playground, and then it's going to output in the desired selection here. So let's actually open this one more time in the playground. Look at the parameters. So response length is 64, temperature is 0, top P is 1, and the rest, frequency and presence penalty, these aren't too interesting here. Now let's do submit again. The code above is a function that takes 3 arguments. Hello. So this isn't really helpful. Let's run it again. One more time. One more time. Okay, yeah, so not helpful. The code above is a function that takes a data frame and a prefix. So this is what it should be in the ideal case, as input, and returns a data frame with the prefix removed from the completion columns. Right. Okay, so not very helpful. Calculate time complexity. This is another example. Find the time complexion of a function. Translate between programming languages. Translate this function from Python into Haskell. Okay, let's try this out. I think we have the same parameters. So best of 1, presence, frequency to 0, top P to 1, temperature to 0. Let's submit. Let's actually translate this function from Python into Go. I'm more interested in Go from a cybersecurity perspective. Okay. Submit. Nice. Okay, so let's actually find a Go compiler, Go interpreter online. You have the Go playground. I think we have to leave the main package. We import the FMT. We have the function main, and inside the function main, I think we can define this other function. I believe so. I'm not quite sure if you have to be very strict with the syntax, with the indentation. Let's actually run predict proba for how does this work? Predict one proba tweet for tweeting X. What does this code actually do? Translate this function from Python to Go. Explain what this function does and give an example of how to use it. And we can simply say here explanation and example. Let's see if it works. This function takes in a list of tweets and returns a list of probability prediction for each tweet. The function loops through each tweet in the list and calls the predict one proba function on it. Awesome! So this is something that actually really works. Example, let's keep on running. So you have the tweet, predict proba tweet, and here are the probabilities for each class. The function that returns a list of probabilities. So this is interesting. I actually modified The first one, the translation from one language into another, into an explanation. So this is really, really cool. Awesome. So, wow, I'm excited about this. Uh, should this actually work? Let's say explanation and example. Explain what this function does and give an example. Let's say, let's actually go back. How do you undo everything that you've done? Simple. Open this one more time in Playground. So translate this function from Python into Haskell, into Go. Okay, so and we say here Go. Then provide an example of it in Go. And then we say here Go example in Go to be even more specific. Submit. Again. What if we say just Go? Example of the function in Go. Let's run it in the Playground here. So let's actually make sure that it's consistent here. So function predict proba. Let's actually copy this one more time and paste it just for reference. Predict proba, and let's run this. Let's see if it works. Unexpected predict proba. Expected for, so non-declaration statement outside of function body. Predict proba, you have the string. What if we don't import everything here? What if we run it again? Predict proba, you have the predict proba. I'm not actually good in Go. I mean, I suck at Go. I don't know Go, so I'm not really sure how this would work. Let's regenerate. Copy and paste again. So we are inside the function main. Should we not be inside the function main with this one? If we run it, it runs. Then you have another function and it fails. The syntax, it could probably fail because of the syntax. So you have open and you have close and you have another close. So that's not okay. Put it again inside main. There's definitely something wrong here. So you open it and then you close it. You open the first one and then you close it. You open this one. You open another one you close this one, and you close the other one. And we have a syntax error here. Anyways, I'm losing track here, so 20 minutes already. All right, let's actually go into, so this is really awesome. Let's look into another example. Explain code. I think this is, we've looked into this. Let's see, open it in the playground. Submit. So this is definition of a class. Here's what the above class is doing. The constructor creates a directory for the log files if it doesn't exist. Exist okay equals true. The log method writes a JSON event and the state method. So it explains the functions inside the class. This is really cool. Remember, it has a memory of, you can actually do 4,000 tokens or so, 4,096. So yeah, this is interesting. Explain code. Python bug fixer. Maybe we'll look into these ones in a future video because this is getting too long. So yeah, super exciting.